We are the Drexel University RASC-AL team, and we've created the Polar Astronaut Sustainment Tube, or PAST, habitat. Our primary goals are to establish a moon base with power, protection, and preservation in mind. The overall purpose of such a habitat is to serve as the starting point for future space expeditions, whether that be further exploring the surrounding surface of the moon or serving as a staging area for Mars missions. PAST accomplishes this with a few key innovative subsystems, including a novel implementation of a protected power system, a communications network that can serve as the cornerstone for additional surface facilities and autonomous vehicles, and a sustainable algae farm to provide food to astronauts. The first innovative development is securing constant power for the mission by attaching electrodynamic regolith repulsion systems to mission solar panels. These will act as transparent shields that let sunlight through to the panels, but keep the sticky regolith off with electromagnetic waves. These shields preserve the long-term efficiency of solar panels and therefore improve the PAST's longevity. The second key innovation PAST focuses on is the inclusion of a mesh LTE network managed from an onboard base station. This network would allow for reliable coverage at extended ranges due to the flexibility of a node-based mesh. It could be further expanded upon by future missions integrating into this network to provide an interconnected communication system supporting multiple tasks and missions at once. Our final key innovation is a tubular photobioreactor designed to limit the amount of food that needs to be brought to the habitat long-term by providing astronauts a steady source of protein in the form of edible algae. The borosilicate tubing structure is designed in such a way to maximize light and nutrient dispersion, and thereby accelerate algae production. Additional subsystems are detailed to support the general requirements of astronauts during a stay in the PAST. To conclude, the innovations of the PAST habitat will be the cornerstone of current and future Artemis missions, as we aim for the Moon and eventually Mars.